Hello, class. It's just me, Mr. Wee. Let's see. Okay, let's continue off with where we left off. We left off with some new set of notes called complex roots. Cases, that says cases where the discriminant is less than 0. So the last thing we kind of went over was this. Your notes, or I'm sorry, the notes that I projected might not look exactly like this, but it's the same problem. It was x squared, or it was a solve x squared minus 16x plus 64. I think technically yours was x squared minus 16x equals negative 64, but it would come out the same way. So don't worry, like you would eventually have to make your equation in your last video, look exactly like this anyways, because you had to move the 64 over here. Then we used the quadratic formula. We found out that we had only one root because ultimately we have only one answer here, and we saw that underneath the square root sign, you have 256 minus 256. That's what's called the discriminant. The rules are if your discriminant is greater than 0, d is greater than 0. You don't have to write it like that. You have two real roots. I can't emphasize it enough. It's not just roots, but it's real roots. If your discriminant is 0, like in this case, 256 minus 256, plus or minus 0, you only get one root because you're only adding and subtracting to some kind of, or just 0. If it was a positive number, again, if your number was positive and it was greater than 0, you would have 16 plus or minus a positive number, meaning, like, let's just say it's 2. This ends up the square root of 4, and you end up getting 2. It's 16 plus 2 and 16 minus 2 divided by 2. But in this case here, you have 16 plus or minus the square root of 0, which is just going to be 0 anyways. Plus or minus 0, it's only going to get you one answer, which is this. We're going to go over a case where the discriminant could be less than 0. So what's that going to look like? Let me give you a problem where you're going to get exactly what it looks like, or what it sounds like. So let's go through an example here. You have x squared minus 4x is equal to negative 13, and it's going to ask you to solve for the roots. And it'll ask you how many roots did you get? How many roots did you find? Okay. So here what we're going to do is we're going to have x squared minus 4x is equal to negative 13. We're going to add 13 to both sides. You have x squared minus 4x plus 13 is equal to 0. And then you just have a, then you just have to define what your a, your b, and your c are. So my a is the number that's in front of x squared, which is just 1. B is negative 4 technically, and then c is equal to 13. And you just plug it into your quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. And then that's going to give me your roots or your answers for x. The cool thing is we already know this situation is going to end up in a situation where you're going to have this number underneath the square root sign less than 0. But let's just see what happens, okay? So then you have negative 4. Let's plug all this in. Plus or minus the square root of negative 4 squared minus 4 times 1 times 13. That already looks like a big number. 2 times 1, because it's 2 times a. And then let's see, that's going to be positive 4 plus or minus the square root of 16 minus 4 times 1 times 13. That should be 52. Quick math right there. Divided by 2. You get 4 plus or minus the square root of, okay, so let's take a look. We have negative 36 divided by 2, okay? So already our discriminant is less than 0. So again, that's going to give me no real roots. But what is that going to look like? So let's figure this out first. Let's take out at least, so let's just look at 36. What are 2 factors we could possibly think of for 36? I'm thinking 9 times 4. And since we have that negative in front, let's just take out a negative 1 as well, all over 2. Let's break down these guys as much as I can. So that's 4 plus or minus the square root of, how many factors can go on to 9? I'm thinking of 2 factors, and there's going to be 3 times 3. That's already a pair of numbers I can pull out. 4 can be broken down to two twos, so it'd be times 2 times 2. That's another pair of stuff. And -1 technically can be broken down into two numbers as well. That's going to be I times I. So look, I could pull out 3 pairs of different numbers on the outside, all divided by 2, so that's going to be 4 plus or minus 3 times 2 times I, all over 2. That's going to give me 4 plus or minus 6I over 2. And then technically I could divide both of these numbers by 2, 4 and 6. So that's going to be 2 plus or minus 3I. So right there, that looks like it's 2 roots, but again, I said the discriminant, I couldn't emphasize enough, if you have a discriminant that's greater than 0, you will have 2 real roots. D is equal to 0. If you have a discriminant that's equal to 0, you only get 1 real root. If you have a discriminant that's less than 0, you have no real roots. This is an imaginary number. So 2 plus that imaginary number, 2 minus that imaginary number, still gives me no real roots. Okay, so let's take a look at what this looks like. Okay, I'm going to plug in this formula. I'm not going to plug in this one, but I'm going to plug in this new form right here. When we set it all equal to 0, I'm going to plug that into the graph to see what that looks like and compare it to my last question. So you're pretty much done with the question now, but let's understand a little bit about what this means before I turn this video off. So that means you should probably watch most of the video just to get an idea. So let's go back. Let's go back even further. This is the first problem, okay? This is the first type of problem in 3-3 that we talk about. Cases with one rational root, okay? What does one rational root look like? We're going to plug in x squared minus 16x plus 64, okay? X squared minus 16x plus 64. One real root. Roots are where you cross or hit the x-intercept. Or the x-axis. I hit the x-axis at that one point. That is one root. Not bad. That's color-coded as red. Let's do in the other problem that we just solved was x squared minus 4x minus 13, or plus 13, I'm sorry. Plus 13. Now look at that. How many times does this cross the x-axis? Well, it does cross the x-axis at an imaginary point, okay? So meaning this, remember on my answer, I got 2 plus 3i, but what does that look like on the x and y axis? It looks like nothing because that's not a real number. Your graphing, or your graph of x and y axis, only accommodates real numbers. There are no actual roots or imaginary roots here. That's why this parabola only hits the x-axis at 0 points. There's no real roots. Whereas the first problem that we did, again, I will show you again what I'm talking about. The first problem that we did, x squared minus 16x plus 64, does have one real root. Okay? Let's see. If I did this guy really quick, let me see if I can. Again, just a reminder what 2 real roots look like. It was x squared plus, let's say, 16 plus, let's say, 4x, let's see. Oh, 8x, let's say. No, let's not do that. Let's do this one here. Got it. X squared plus 9x plus 20. If I did this into the negative b plus or minus the square root of b squared minus 4ac all over 2a. If I plug that in, okay, I should get x is equal to negative 5, and I believe it's negative 4, if I did that correctly. So let's do that, x squared. So I should get 2 roots for that guy. So that should be x squared plus 9x plus 20. No, it doesn't look like it. Oh, look at that. My last problem, I know it doesn't seem very obvious. On red, I'm highlighting red right now. That was the first problem here. I'm going to highlight this. This one here had one root, because it only crosses the x-axis at 1 point. Okay. Down here, I put in something where I knew I was going to get two roots. And the two roots are here, -5 and -4. Okay. I know I solved that pretty quick, but you can trust me that the discriminant, if you found out, the discriminant here would have been greater than 0. Okay? All right, guys. That's all I'm going to do right now. You guys have a great day. Bye.